the last week for seniors. We have a few seniors in this class. Most of this class is juniors, actually, but we do have some seniors in here. So this is your last week, your last assignment. Finals are next Monday and Tuesday during class. So if you have to take the final, it'll be during class next Tuesday. So the way that would work is we'll come to class, my juniors will have class, and I'll do a breakout room for any seniors that need to take the exam. And you'll take the exam in class in a breakout room while the rest of us are going through next week's stuff. So for exemptions, I'll be sending out by Friday, but no more than 4 absences, no more than 4 tardies, no more than 4 absences in advisory. That's the bad one because it makes you take all your classes finals. No missing assignments and no grade below 75%. So if you can meet all of those requirements, you can be, of course, no fees or fines, but we don't have fees or fines in here. And looking, there's not a whole lot of missing assignments, but I do see a handful of missing assignments throughout the semester on several students. You missed one here, you didn't do the collage, or you missed an assignment or something somewhere. So you should go back and look at that because Friday I'll be sending out the exemptions. So you got to have all your work in Friday morning by 7 a.m. to be considered for an exemption. But I will still take work until Tuesday morning next week at 7 a.m. for your final grade, just turning it in to get a grade for it. But if you want to turn it in to be exempt seniors, it needs to be in by Friday morning at 7 a.m. So I would go back and double check and make sure there's no missing assignments. Go into Buzz, go to that grade screen, make sure everything has a grade and that there's nothing missing. I got to get, I got a lot updated last Friday. I think I got all the grading caught up from when I was out for a week 6. So it should be good in there. So it should be accurate, especially in Buzz it's accurate. And Home Access Center I'll have upgraded here in the next couple of days because I got to get all that ready and upgraded for exemptions for seniors. And so all of my classes have some seniors. Some of my classes have a lot of seniors. This is just a few seniors in this class. So, and hopefully, like I say, hopefully you're sent. I'll have that attendance report sent to me and I'll know all that and get that sent to you. Okay, so gosh, this cough is going to drive me nuts. Let's look at the lesson this week, especially since the lesson for seniors. Those of us who are not going to be leaving as seniors, we'll have one lesson next week. And then the week after that will be our semester final, which again, everyone can exempt if you meet all the qualifications. So there's no classes that you can't exempt this semester. So yes, hopefully everyone will be exempt on the next week. And then we've got that weird day after Memorial Day that is an official school day. So finals will be over then, but we will have some other. I think we have some community service opportunities, and we'll have some other things going on. And I don't know. We'll learn more about that as we get closer to it. But let's go take a look at what we have in Algebra 3 today. 0B, Algebra 3. I'm way behind since I got sick. See, I've got some missing assignments myself right here. Some of the matrix stuff that I can get finished up. I'll get that done. And I didn't get quiz 4 done from last week. So hopefully you should be 100% done with matrices. Unlike me. See, I got to take the final right now. I got missing assignments. I'll get those in. But we've got rational functions and asymptotes that we're looking at today, 8.06. And the next week, we're going to look at graphing rational functions, which we may look at a little graphing today just to kind of tie in asymptotes and get that in our head, how that's working. So next week will be pretty simple. But let's look at 8.06. Like I say, we're just got 2 lessons left that we're going to look at before the final. Just this one lesson for you seniors. Next week's lesson would not be on the senior final because, wouldn't do that to you. All right, rational functions and asymptotes. Let's take a look at that, see what that entails. Scenic overlook. Remember, this is one of those lessons that we look at the scenic overlook and then we stop when we get here. This gives more information down here, and it goes into more detail and more sample problems. but all of it's covered up here in the scenic overlook. So up until now, we've really only worked with graphs that are continuous, right? There's no breaks in the graph. They go from one side of the graph to the other and all on to infinity. Because the domain of polynomial functions has been all real numbers. So we're going to extend and look at functions that are not all reals. So a rational function, let's talk about what a rational function is. It's basically the quotient of two polynomials. So let me just write an example then. Let's pull up our little camera here. Because before we get too much into this real mathy talk, I want to make sure we understand what this mathy talk is saying. Okay, so a rational function would be like f of x equals 2x squared minus 1 over 3x to the third plus x plus 4. Something like that, where we're talking about a polynomial expression on the top and bottom of a quotient, of a ratio, a fraction type looking thing. I'll lower this down a little bit so you get a better look at it. But this is what a rational function is. So when we talk about that, we're talking about something a little fancier than we generally have dealt with. So P of x divided by Q of x, right? Whatever those are. And this says where P of x and Q of x do not have any factors in common, and Q of x is not 0. See, that's the important part of this equation. If this is 0, we got a problem because we're dividing this by 0. We cannot divide by 0. So this would have a case where whatever x would make this equal to 0 would not be allowed, right? We would say x cannot be whatever that number is. We'd have to solve that. 3x to the third plus x plus 4 equals 0. And x would not allowed to be that because it wouldn't exist. So near the point that Q of x equals 0, the graph of the function may increase or decrease without bound. So let's take a look at what they're talking about. Let's just graph this equation that I just totally made up, so I have no idea what it's going to look like. Other than it's going to have an asymptote wherever that denominator would be 0. So let's do 2x squared minus 1. And I need to put that in parentheses so it puts it all in the numerator. And that's going to be divided by 3x to the third plus x plus 4. Okay. So obviously, if x is 2, it looks like, or negative 2, I mean, see, negative 2, this graph is not going to exist at negative 2 because it said where it increases or decreases without bound. At negative 2, let's go ahead and put that on there. X equals negative 2. Oh, negative 1. Negative 1. Oh, this is going by 2. So, yeah, let me fix that. I don't like little minor grid lines. Make it go by 1s. So when the graph gets close to that point at x equals negative 1, the right side of the graph increases towards infinity very rapidly, where the left side goes towards negative infinity very rapidly. So this is an asymptote. It's a vertical asymptote because it does not exist. If we put negative 1 into there, 3 times x to the third, negative 1 to the third is negative 1. So it'd be negative 3 plus another negative 1 plus 4. So yeah, negative 1 would be what we would have on this. X cannot be negative 1 because that's what makes this 0 down here. And we also see the top. If we want to know the zeros, it would be where the numerator is 0. So at 2x squared minus 1 equals 0 is where it's going to cross the x-axis. So we add 1, 2x squared equals 1. Got to divide by 2. X squared equals 1/2. Square root of both sides. So x equals the square root of 1/2. Which we could simplify, but we're just going to leave it at that. And when we see that, it's right there, 0.70711. That's where we see it come across the x-axis. And also at negative 0.70711, because the square root of that's going to have a plus and a minus All right, so that is where it crosses the x-axis. So that's the zeros, and that's the asymptote at x equals -1 right there. So to see this, it says let's look at the function 1 over x. All right, we can do that. 1 divided by x. See, at 1 under x, if x equals 0, that's the asymptote, because that's where the denominator would be a 0 at. So you see right there at the y-axis, it goes way up on the right side, way down on the left side. The domain of the national function will occur at all real numbers except those values at x equals 0, right? That makes the denominator 0. So this goes all the way negative to infinity. The domain includes all x's, all real numbers, except for x equals 0. Says what happens as x approaches 0 from the positive and negative side? Well, we saw on here, it takes a sharp turn up and down. But if you just plug in numbers, when x equals -1, then the function equals -1, 1 over -1. When x equals -0.1, it's going to equal 10, because 1 divided by, excuse me, it's going to equal -10, because 1 divided by -0.01 is 10. So you get -0.001, -1,000, because it gets big really fast, because you got 1 divided by a very, very small number. And then on the right side, you got the same numbers as positives: 1, 2, 10, 100, 1,000. So you should graph this function to visualize it graphically, which we did, and see how it approaches on both sides. So the definition of vertical and horizontal asymptote states the line x equals a is a vertical asymptote if of the graph of f, if f of x approaches infinity or negative infinity as it approaches it from either side. So as we can see, when it approaches x equals 0, suddenly from either side of the graph, it's going to either approach infinity or negative infinity. So that tells us that this is an asymptote if we look at it on a graph. The line y equals b is a horizontal asymptote. If you see that, like right here, y equals 0 is a horizontal asymptote, the x-axis, because as the graph is going to negative infinity, it's approaching closer and closer and closer. Oh, it's picking up back there. It approaches closer and closer and closer the farther it goes. And then on the other side, it's coming in from the top, but it's getting closer and closer. But it will never touch asymptotes. Now, that's not necessarily true with the horizontal asymptote, because these rational graphs can do something really weird. Sometimes you may have this dip below the asymptote and then come back and approach it forever without touching it. But it may cross it first, because rational expressions do some really weird graphs. It says review your text to see examples. So for the rational function, p of x divided by f of x, q of x, says where p and q do not have any common factors, the following applies. The graph of f has vertical asymptotes wherever the denominator equals 0, and the graph has at most one horizontal asymptote. So this is what we need to, and then they just have some example problems. This is what we need to dig more into. How do we figure out what the horizontal asymptotes are? Okay. We need to put this in our notes, because they don't have a really good definition for us in the lesson there that we're going to be able to read and understand simply. So for vertical asymptotes, x equals whatever x would make the denominator equals 0. So our asymptote is going to be whatever x that would make, like, for example, that right there. So we're going to just highlight that as an example. Vertical asymptotes. x equals denominator equals 0. So, for example, right there, for this one, we have a nice example. Horizontal, calculating horizontal asymptotes S are based on the oh, degrees of the numerator and denominator. Okay, so the horizontal asymptote, that's this direction, are based on the degrees of the numerator and denominator. So, for example, we need to illustrate this. If we have f of x is, let's do 2x over 4x squared. Here's our first situation. Since degree of denominator, what is the degree of the denominator? Well, let's get our little pin here. All right, it's squared. The degree of the denominator is 2, is greater than degree of numerator, which is, it's an assumed 1, right? Because it doesn't have 1. It's a 1. Horizontal asymptote is y equals 0. It will have an asymptote at y equals 0 because the degree of the denominator is larger than the degree of the numerator. That's the first case. The second case, if degree of numerator is greater, bet you know where I'm going with this, huh? Then degree of denominator, there is no horizontal asymptote. Oh, yeah, that's right. Numerator is greater. The numerator is greater than the degree of the denominator. There's no horizontal asymptote. So that would be in the case of f of x equals, let's say, 3x to the third over 2x squared plus 1. We've got a third degree in the numerator and a second degree. This will have no horizontal asymptote. Let's take a look at that just so we can see on a graph what we're talking. So first, let's do the first one that I did. It was 2x divided by 4x squared. And there's that horizontal asymptote at y equals 0. Then the second one we just looked at was 3x to the third. And it's divided by 2x squared plus 1. So there's no horizontal asymptote. It continues from negative infinity to infinity. No horizontal asymptote. If I suddenly change to make that fourth degree on the denominator where it's larger, now we're back to that horizontal asymptote that it approaches. But now I told you it gets weird. Look, it actually does cross the asymptote, but going both directions on the ends, it's approaching y equals 0 as a horizontal asymptote. All right, that leaves one case that we haven't looked at, right? There's one other possibility. If the degrees are equal, then the horizontal asymptote is the ratio, you're thinking, we're using big words here, of the coefficients of the largest terms. So we're definitely going to write down an example of this. So if we have, so the degrees are equal, then the horizontal asymptote is the ratio of the coefficients of the largest terms. And what we're saying is if we have, let's say 2x to the third plus x squared, just for the fun of it. And down here, we've got 8x to the third minus 1. Look, the degrees are equal. These are both third degree polynomial expressions. So in that case, this is the largest term. We take the ratio of the coefficients. So the asymptote is y equals 2/8, which of course we simplify to 1/4. That would be the horizontal asymptote. If they're equal, we just take the coefficients and set them up as a fraction. So let's put this in Desmos and take a look at that. So the top was 2x to the third plus x squared. And then the bottom one was 8x to the third minus 1. All right, minus 1. Change this to the third. And I made this an 8. So this is the y equals 1/4 is the horizontal asymptote. See, as it's getting closer and closer, that's the line that it's getting closer to on both sides. You just take that coefficients. Now, if we want to change the coefficients, let's say that the coefficients are f of x equals, we'll say this is 12x to the fourth over 2x to the fourth minus 1. These are both x to the fourth, so the horizontal asymptote is going to be at 12 over 2, because that's the coefficients, which means it's at y equals 6, because 12 divided by 2 is 6. So let's look at that. Let's change this equation to be y equals 12x to the fourth divided by 2x to the fourth minus 1. We have a horizontal asymptote. Now, see, this is not a horizontal asymptote. We have two vertical asymptotes. So we have a vertical asymptote at -1, and we have a vertical asymptote at 1, or actually, it looks like it's probably smaller than that because it does It's like a 0.8 or something, or 0.9 vertical asymptotes. But the horizontal asymptotes up here at y equals 6. That's what we were calculating. What's the horizontal asymptote? The vertical asymptotes would be wherever 2x to the fourth minus 1 equals 0. We could calculate that. So we can see on the graph, it's less than 1. It's some decimal number. But that is how we find the horizontal asymptotes. 3 cases. Numerator less than the denominator, if they're equal, or the numerator is a higher degree than the denominator. All right, let's see. Let's take a look at these. What are the vertical asymptotes? What's the horizontal asymptotes? X minus 3 over x plus 2. Let's talk about the horizontal asymptote first. The degree of the numerator is 1. It's x to the first. The degree of the denominator is x to the first. What's the coefficients? Well, they both have a coefficient of 1, so it's 1 over 1. So the horizontal asymptote for this first one is just going to be y equals 1. And if we're not sure, we can always graph it. But let's look at the vertical asymptote also. The vertical asymptote is wherever the denominator equals 0. So x plus 2 equals 0. That's when x equals negative 2. So this will have a vertical asymptote at x equals negative 2 and a horizontal asymptote at y equals 1. So let's look at that. X plus 3. 3. No, get rid of all that. Divided by x minus, x plus 2. Whatever, plus 2. Plus x minus 3 plus 2. Okay, minus 3. So we said there's a vertical asymptote at x equals negative 2. And there it is. We see it in green. That's that. And we said the horizontal asymptote is y equals 1. And there it is. So look at Desmos to double check ourselves. That is exactly correct. Those are the asymptotes for this rational function. Okay, look at this one. X plus 1. X squared minus 4. In this case, x to the first degree, x second degree, the denominator is larger than the numerator. So if we go back to our notes and say, okay, the denominator is greater than the numerator, so this will have asymptote at y equals 0. Horizontal asymptote. So this middle one is a horizontal asymptote at y equals 0. And x squared minus 4, that is where the vertical asymptotes will be. So wherever x squared minus 4 equals 0, add 4. Wherever x squared equals 4, square root. So x equals plus or minus 2. There's 2 vertical asymptotes, one at 2 and one at negative 2. So let's take a look at that. Change this one to x plus 1 on top. Change this to x squared minus 4 on bottom. And we said there's 2 vertical asymptotes, one at x equals 2 and one at x equals negative 2. And we can see those. Let's turn off the asymptotes where we can just see the original graph. See, we got a 3-piece graph because you have a horizontal asymptote at x equals 2 right over here. That's going to divide those 2 pieces. And then we have one at negative 2 over here. And then in the middle, you've got this piece that goes towards infinity on the left and negative infinity on the right. And then we said that this was at y equals 0. So it's just the x-axis for the horizontal asymptote. And this one's not going to have a horizontal asymptote because the numerator is second degree and the denominator is only first degree. But we will have a vertical asymptote at x equals negative 1. So let me see if this works where you can actually check your answers on that. Yes, it does look like it works. Oh, so there it is, even including the graphs. If it loads the graphs, it's still loading. But yeah, no horizontal asymptote in the last one. X equals negative 1. But it's taking forever to load that. I'm not going to wait on it. That's the whole lesson. We're just looking at the vertical and horizontal asymptotes. Oh, state the domain. That's what possible x's they are, right? Well, that was the first thing we talked about, is it's going to include all x's from negative infinity to infinity, except for any x that would make the denominator a 0. And if you're not sure, just graph it and say, are there any x's that it cannot be? 13 over 10 minus x. 13 over 10 minus x. Yep, look, there's a place where there's an x that's not included. It goes to negative infinity and goes to infinity, except for where x equals 10 right there. State the vertical asymptote. That's anywhere that the denominator equals 0. What's the horizontal asymptote? Remember, that's based on the degrees. State the horizontal asymptote, again, based on the degrees. And give an example. So you're going to make up your own on this bottom one. Give an example of a rational function that has no horizontal asymptote, and the vertical asymptote is x equals 1. So there's an infinite number of correct answers there. You just got to go back and look at, how do I make it where it has no horizontal asymptote? And how do I set the vertical asymptote at x equals 1? Five questions. As long as you got in the notes how these work, the degree of the numerator and denominator determines the horizontal asymptote, and whatever the denominator makes 0, whatever x that is your vertical asymptote. So hopefully you won't have a lot of trouble with this. 5 questions. Try to just simplify it down. We're not looking at, there's other things you do with rational functions, like we're holes in the graph. We're not talking about holes and dealing with all of that. We're just looking at the asymptotes. And next week, we'll look more into the graphs of that. And that's our last 2 lessons we're going to have. Seniors, this was your last lesson. So get this turned in right away. Be done with it. Go back. Make sure you don't have missing assignments. If your grade is below 70, I don't know if I remember if I mentioned that one. Your grade has to be 75% or higher in order to be exempt as well. So if you look at your grade and it's like, oh, man, I got a 73, go back and see what you can redo. Let me see. Oh, I had a low grade on this assignment. Let me go redo that. Or, oh, I didn't do too well on this quiz. If whatever you want to redo says, sorry, you're out of attempts, just email me. I can reopen it. I can reopen it and let you go back and redo that, because I want you to have that opportunity to be exempt if you're going to qualify. If you don't have too many absences, advisory absences, all that stuff, I'd love for all of you to qualify and not have to worry about it. And remember, if you do qualify to be exempt, you can decide to take it. Oh, I got a 78.5. If I took the final and did really well on it, I could raise my grade up to a B. Great, give it a shot. If you're exempt and you score a 40 on the final, I just throw it out and pretend you never took it because you were exempt. You didn't have to take it. That's what's great about being exempt. You can take it to raise your grade, but it can't hurt your grade if you are exempt. So, all right, guys, I'm going to let you go. There's no need to keep you for the rest of the class. It's too close to summer for that, right? We're already in the May. It's the 6th. We don't have much left. Seniors, I'm excited for you. You're getting there. You're right at the end. We'll get exemption emails out to you. If you got any questions, email me. This is a B-Day Friday, so I'll be here Thursday and Friday. If you got questions or anything you need help with, come see me. Otherwise, have a great week.